So now we're going to look at the tangent ratio. Tangent is part of a larger part of math called trigonometry. All the trigonometry that we're going to be looking at only deals with right triangles. So the triangle has to have a 90-degree angle, otherwise we can't do any of the trigonometry we are going to learn. So when you're doing right triangle trigonometry, you have to identify where the right angle is. And then oftentimes the right angle will be in the corner with a flat side and a vertical side, which means that if it's set up that way, the side that is slanted is called the hypotenuse. It's the longest side. It's across from the right angle. It's got a funny name, hypotenuse. So from there, depending on which angle you're talking about, we're going to use angle A. The other two sides are referred to as either being opposite or adjacent. Opposite means opposite, it means across from it, not next to it, on the other side of the triangle. So if you imagine this being like a, I don't know, like a wave or whatever in the ocean, you throw in a pebble and this is like a wave, it would go all the way out and it would hit the opposite side. So if you imagine the wave traveling outward like they do, the side that it would touch would be the opposite side. The adjacent side, adjacent just means next to. So there are two sides that it's next to, but one of them already has a name in hypotenuse. The other one is the adjacent side. You can also always identify the adjacent side by looking at the angle that we are referring to, in this case angle A, and the right angle. If you put a dot at the angle you're referring to and a dot at the right angle, a line connecting those 2 points is the adjacent side. So it seems simple, it seems easy, but if you cannot identify opposites and adjacent sides, you can't do this. You're going to mess up every problem if you can't identify them. So then we get to what is the tangent of an angle. Tangent is actually a ratio. Way back, I think it was in ancient Greece, they were studying right triangles and working with them, trying to figure out all their properties, and they found that no matter how large the triangle was, if this angle was a certain degree, like 30 degrees, no matter how large the triangle was, when they looked at the ratio of the opposite side over the adjacent side, you always got the same number. You would always get the same number, which is actually, well, I won't go into it yet, but you always get the same number, which would make sense because in our last chapter about similarity, they will all be similar because they've got a 90-degree angle and a 30-degree angle. So if they're similar, they're going to have the same ratio. That's the definition. So they just ended up taking it to the next step, and they pretty much, when trigonometry started, they just made a huge list. They had every degree, and next to it they had every ratio, like all the decimals. So whether it was like 0.6 something or 0.732, whatever it was, they just had a list of all those decimals, and that's how they used it. But tangent is always the opposite side. It's just a name they made up to talk about it. Tangent is the opposite leg over the adjacent leg. When you hear about trigonometry, a very common phrase to help you remember is SOHCAHTOA. We are specifically, since we're talking about tangent, we're focusing on this TOA part. which makes sense, and this is where it's useful. Tangent, T, equals the opposite side over the adjacent side, O over A, OA. So it always tells you the function and opposite and adjacent. So today right now we're focusing on TOA. Tangent is opposite over adjacent. So moving forward a little bit, here's our right triangle. It's a right triangle, so we can do sine, cosine, tangent. We'll learn about sine and cosine in the future. Of angle A is what we're looking at. So if we're going to figure out what angle A is, we're going to write the ratio for angle A, tangent of angle A. So you have to take the opposite side. Remember, for opposite, you look as if this was a wave that was kind of rolling out. We would get over here to the 18. So the opposite side is 18. The adjacent side, that's the side that's next to the angle, between the angle and the right angle, that's 24. You can even reduce that, divide by 6, you get 3/4. For angle B, now you're changing the reference. So whatever you had, you have to either ignore or erase now. Now we're looking at angle B. Now when we look at angle B, if you imagine that as a wave shooting out towards the other side, that's the opposite side, 24. Over the adjacent side, between the angle and the right angle, that's 18. Again, you can reduce that, divide by 6, you get 4/3. So, big idea, so I put a star here next to what we're going to write. What's the relationship between the ratios for tangent A and tangent B? So when you just switch the angles, what happens to the ratios? We went from 3/4 to 4/3. There's a fancy math term for that. The fractions flipped, fancy math term is they are reciprocals. In a triangle, if you know one of the tangent ratios, you're trying to find the tangent ratio for the other angle, you just flip it. Just take the reciprocal. It makes sense because the only thing that changes is which side's opposite and which side's adjacent. So here we are, angle Q. We have tan Q. Sounds like thank you. Taking the opposite side, 15, over the adjacent side between the angle and the right angle, that's 36. Yes, you can reduce that. Divide by 3, 5/12. Oh. Up here we forgot, it also says right as a fraction and a decimal. As a decimal, that's 0.75. As a decimal, that is 1.667. Oh, it says 100. Erase one of those sixes. So 5/12 for this ratio. You can get that as a decimal. 0.41. It's into the nearest hundredth. So rounded to the nearest hundredth, it's 416. It would be 42. For angle R, let's apply this concept we just wrote up here in, next to the star. If you're switching the angles, the only thing that switches with the ratio is going to be the reciprocal. So instead of 5 over 12, it's going to be 12 over 5. You switch the angle, we take 36 over 15 and reduce that. It reduces to 12 over 5. And then as a decimal, it's 2.4.